All right, this section we're going to be solving equations again, or systems of equations using nonlinear equations, right? Notice the top one here, y equals x minus 5, that's a line. Those bottom ones are hyperbola. We haven't even learned about hyperbolas. Wait till your next class to graph those. But we can still do these algebraically. So we're going to be using the elimination and the substitution methods today on this. So let's take this first one. Notice y is already solved for. Right, so I'm going to use substitution. Right, so number one, I have a variable already solved for. I'm going to plug it into the other one, x squared minus y squared equals 5. So here's my y. That's going to go in right there. Minus y squared equals 5. Plug that y in. Y is x minus 5. And let's expand it. X minus 5 times x minus 5 is x squared minus 10x plus 25. Notice those cancel, and I'm left with 10x minus 25 equals 5. Add 25 to both sides. Divide by 10. So it looks like x is 3. Now we know that x is 3. Okay? So at this point, I can plug it into either one, but it's got to satisfy both equations. So for example, if I throw it into this one, 9 minus y squared equals 5. I subtract 9, divide by negative 1. See how it spits out both plus and minus 2? But it's got to satisfy both. In other words, if I used x minus 5 instead and I plugged the x in, it only spits out negative 2. So I can only go with the negative 2. When x is 3, y is negative 2. That's the only place, that's the only point that satisfies both equations for that line and the hyperbola. In fact, let me show you on Desmos what this looks like. If I plug in y equals x minus 5, there's that line. Now let me plug in the hyperbola. And you see how they only cross right there at that point. 3, negative 2 is the only spot where those two cross, right? Again, I don't expect you to know how to graph that hyperbola because we don't cover that in this course. All right, let's do this next one here. xy equals negative 2 and x plus 2y equals 0. So I'm going to go with substitution again. And I'm going to take that bottom one because it looks pretty easy to solve for x. Notice x is negative 2y. So if xy here, now I'm going to plug it into the other one. xy equals negative 2, and I plug x in. So I have negative 2y times the y is negative 2. In other words, negative 2y squared is negative 2. Divide by negative 2 on both sides, and I get y squared is negative 1. So I square root, and I get plus or minus the square root of 1, which is 1. So y could be 1 or negative 1. And let's go ahead and let's do it for the scenario. If we know y is 1, and then we can just plug it in. Subtract 2, negative 2. Negative 2 is x, y is 1. How about if y is the negative 1 now? Add 2 to both sides, so when x is 2, y is negative 1. And similarly for, you could have used xy as negative 2 and you'd have got the same x values there for 1 and negative 1. So let's take a look at this graph. So we have negative 2, 1, and 2, negative 1. So first one, xy equals -2. In other words, y equals -2 over x, right? So it looks kind of like -1 over x, except it's reflected about the x-axis and a vertical stretch on that. And then x plus 2y equals 0, that line. You see how they hit right there, -2, 1. They also hit right there at 2, -1. So there's our 2 points on the graph where those two cross. All right. Well, notice on this one I have x squared and a y squared on both of them, right? On both of them. So solving for one of the variables be kind of messy because I'll get a plus minus square root scenario. So I'm like, I don't really want to deal with that. So what I'm going to do is I'm going to use elimination on this instead. And I'm going to go ahead and let's get rid of the y. So notice on the bottom one I have 3y squared. The top one, I just need to multiply that by 3 and I'll have -3y squared. So this becomes, bottom stays the same, gone. So I have 5x squared equals 5 divided by 5, square root, square root. So it looks like x ends up being plus or minus 1. Okay, so if x is 1, plug it in. If x is -1, plug it in. So we get plus or minus 1. So when x is 1, I get positive 1 for y. When x is 1, I also get -1 for y. Let's do it over here when x is -1. Looks like we get a plus minus y here. So when x is -1, I get a positive y, 1. When x is -1, I also get a -1 y. Again, it's got to satisfy both, so I could throw it in, make sure I could throw it into the other one, and it still will spit out those points. Let's take a look at the graph of this. So I have, let's see, I got x squared minus y squared equals 0. And the next one I had 2x squared plus 3y squared equals 5. And here they are. There's that point 1, 1, 1, -1. Then I have -1, 1, and -1, -1. Right? So that's the 4 spots where the black and the green graphs cross. Okay. We're going to do this next one with elimination as well. Oops. Notice, and I'm going to use let's go ahead and let's get rid of the x's this time. I know it's more work. You don't have to do it that way, but if I do, I multiply that by -2. So I'd have -2x squared minus 2y squared is -20. The bottom stays the same. And the reason I did that is because this one has a y squared, that one has a y. So it's not like they cancel each other, right? They have different degrees there. So I'm choosing to get rid of the x's. So that's gone. So I'm left with -2y squared minus y is -21. So now I'm solving a quadratic. Let me get everything on the one side equals 0. So add 2y squared, add y. And so here's what we end up with. So 2y plus 7 equals 0. Subtract 7, subtract 7. So y is -7/2, or y is 3. Well, let's go with the negative 7/2. So let's go with y being negative 7/2 first. Let's take that bottom equation. Subtract 7/2 on both sides. So 2/2 minus 7/2 is negative 5. Or I'm sorry, negative 2/2 minus 7/2 is not that. It's negative 9/2. There we go. Divide by 2 on both sides. Now the problem is when I square root this is an imaginary number. The square root of a negative 9/4. That's imaginary. We're not working in the imaginary numbers. So you're like, throw that out. We're just trying to see where these graphs cross on the real Cartesian coordinate system, right? The x and y plane. So now we're just going to go with y being 3 then. Add 3 to both sides. Divide by 2. So a plus or minus 1. So I have a positive x being 1 and a y value of 3. Or x could be negative 1 with a y value of 3. All right, again, it's got to satisfy both the originals. So let's take a look at what this looks like, the graph of this. X squared plus y squared equals 10. That was a circle with a radius of the square root of 10, circle centered at 0. The next one's a parabola, 2x squared minus y equals negative 1. There's that parabola, and you can see they hit right there at negative 1, 3 and 1, 3. Those 2 points that we had equations for. All right, let's keep going here. Y is negative root x. I'm going to use substitution. I've already got y already solved for. So substitution, I already know y is negative root x. Let me throw that in for y. Y is negative root x. Well, negative root x times the negative root x is a positive x. Now I want to expand that, so that's x squared minus 6x plus 9 plus x equals 5. Get one side equals 0, so x squared minus 5x, 9, and then subtract 5 both sides, so plus 4. So 1 and 4. So if x is 1, and it's if I plugged it into the second one, into this one right here, the 1, notice I have a y squared, so I'm square rooting. It's going to kick me out 2 different y values. But this has got to satisfy both. So what I'm going to do is, I know y being negative root x, if I plug it into that one, it's only going to spit out the one y value. Remember, it's got to satisfy both. So if this one's restricted to only the one y value, that's the one I got to go with. So when x is 1, y is only negative 1, and then x could also be 4, we said, and I'm going to put it into the one that only has one y value for an x value being 4. So when x is 4, y is negative 2. And I'll show you that visually with y being negative root x. So that's the square root function reflected about the y-axis. The second one's a circle centered at 3, 0 with a radius of 5. I'll show you that here. Y equals negative square root of x. There's this negative square root function. And then the next one was the circle, x minus 3 squared plus y squared equals 5. And there it is. There's that first point, 1, -1, and there's that other point, 4, -2. And like I said, if I didn't put it into the circle when I had x being 1. I didn't put it into the circle because it would have spit out the 1, 2 up here and the 1, -1, or whatever that is. 1, 1, I'm sorry, up here, and the 1, -1. That's why I plugged it into this square root one, because I knew there's only one y value on that. So make sure the solution that you submit satisfies both of the original equations when you're doing these. And then we got one more here. How would you handle a real messy 5 over x squared minus 2 over y squared equals -3? And your big hint is, well, let's let u be 1 over x squared and v be 1 over y squared. And let me rewrite this another way. Here's my first one. So u is 1 over x squared, so that's like 5u minus 2, 1 over y squared is v. Right, there's my first one. And then the second one would be 3u plus 1v equals 7. So now I'm just dealing with these ones without all the messiness of those fractions, right? And I'm going to go ahead and, we could, let's use elimination on this. And so I'm going to multiply this one right here by 2. So we get 6u plus 2v equals 14. This one stays the 7, same. So we got 11u equals -3 plus 14, 11 divided by 11. So u is 1. So now we know if u is 1, I could pick either of the originals. Let me just do 3u plus v equals 7. Subtract 3 on both sides, so v is 4. So if u is 1, then what's our actual x? U is 1, because we know we made that substitution. U is 1 over x squared. Multiply both sides by x squared. Square root, plus or minus 1. Right? And then we know v is 4, and v is 1 over y squared. V is 4. Multiply both sides by y squared. Divide by 4. Square root. Square root of 1. Square root of 4. So we got plus minus 1, plus minus a half. And it's got to satisfy these originals. So I have when x is 1, y is plus or minus a half. When x is -1, y is plus or minus a half. And these will satisfy the original system. I'll show you with the graph here. First one is 5 over x squared minus 2 over y squared is -3. There it is. So there's that point. 1, 1. I'm sorry, that's 1 comma a half. Not sure why it's not showing that, but that's where they hit. And there's 1 negative a half. There's -1 a half, and there's -1 negative a half. And that's all our points there that we found algebraically as well. Well, thanks so much for watching. We'll see you guys next time.